In this lesson, we will learn how to calculate pH. As you know, this is the pH scale. pH 0 is very acidic. That means it has a lot of H pluses in the beaker, more H pluses than OH minuses. This one is basic. It has a lot of OH minuses. Okay, so we're going to figure out where these numbers come from. So where do the pH numbers come from? Since H plus and OH minuses concentrations are so small in a lab, we will be using very small concentrations, as small as 1 e negative 14. It is not very convenient to always write 1 times 10 to the negative 14. Wouldn't it be easier just to put that number down as 14, so pH 14? So this scientist, Soren Sorensen, all he did was he took the negative log of the H plus concentration, or the molarity. So the symbol that we use for that is a bracket with an H plus. All he did is he logged it. He took the negative log of that number, which then we're able to get the power of 10, which is negative 14, multiplied by negative 1, becomes a positive 14, and that is where the pH comes from, uppercase H. Okay, so the pH stands for potential for hydrogen because it's talking about the molarity of the hydrogen. Okay, so the pH scale is nothing more than a spectrum from very low concentrations to high concentration, a range of numbers. So this column is just the molarity of the H plus. Let's focus on the H plus for now. Let's say that you have a 1.0 molar H plus beaker, okay? In the next beaker, the concentration goes down by a power of 10. So now it's 0.1 molar H pluses. And the next one goes down by another power of 10, 0.001, and so on and so forth. So as you can see, I filled in 0.1, 0.01, 0.001, and the concentration of the H pluses gets lower and lower and lower until we get over here. This is 1 times 10 to the negative 14, very little amount of H pluses. If there's not very much H pluses, that means there are a lot of OH minuses. This is very basic down here, where on the very top, you have 1 molar, and it is very acidic, a lot of H pluses compared to down here, okay? And in between, this is 1 times 10 to the negative 7. It is in the middle, so it will be neutral, where you have equal amounts of H plus and OH minuses. As you can see, this is a scale of the molarity of H pluses. You can already see how tedious it is to write all these zeros to communicate how much H pluses that are there. One way to do it is by using scientific notation. This is 1 times 10 to the 0 power because you're not moving. 10 to the 0 power means equal to 1. Okay, so, or you can write as 1 E0. 0.1 can be written as 1 times 10 to the negative 1. This is 1 times 10 to the negative 2, and so on. So as you can see, I've written in all the molarity in terms of power of 10, all the way to 1 times 10 to the negative 14. It is still quite inconvenient to write all these numbers. Why can't we just say the power of 10? So this is going to be pH 14, as you can predict, 13, pH 0 over here, and pH 1. To do that, to get the power of 10, we can use the formula, which is we have to log that molarity. As you can see, 1 molar is the same as 1 times 10 to the 0, which means if we log this number, we will get 0 because that's the power of 10. Okay, so the formula is right here. To get the pH, all you have to do is log the molarity, which is 1 times 10 to the 0. Okay? To do that, the power of 10 is 0, therefore the pH will be equal to 0. Okay, you can, if this number is not 1, you have to plug it into the calculator, and let me show you how to do that.